Yesterday was the first day you saw it. It was probably challenging. My ears ringing. Hold on.
Somebody talking about you?
Yeah. It's from my wreck.
Your ears are burned.
No, it's ringing like there is a supersonic. Mm-hmm.
Burning.
The one where I got rear-ended and I was at a
Oh, I
stop.
told you about the time that I got a wreck.
I was at a stop waiting to turn
No, you
left.
said you hit something on the interstate.
Oh no, that was not a wreck.
suitcase.
That was a Rubbermaid
Tell you
container.
remember that time that
Wide
I got a
open.
wreck?
Wide open. Yeah, and I've learned when
So
you
terrible
call your
night.
insurance company that you always say the object was flying in the air. Because then that goes under comprehensive, which is not your fault. But if you say, I hit it, then it's your fault, it's collision, and you have to pay the deductible.
So if the car's flying through the air and it hits me,
You don't have to pay the
I
deductible
promise
if
no
it's
matter
not
what I say from now on, it will be flying in the air.
if your deductible's not already paid.
Or you can say it was moving, but you, I mean, no, an animal doesn't fly
It
in
was
the air
flying.
until you hit it.
Well, that's
No.
not fair. It runs up
the
front of me.
air, Taylor, the airplanes ain't even deployed.
Maybe not, I mean,
Birds fly.
Uh-huh. If the
That's
car
true.
in front of it hit it, it would fly over the car and then hit me.
Exactly.
that's true.
That's what I was saying.
No, this is
You
from
know, I
the
had a
Part in front of me.
airbags.
I
It
had a
started
bird.
flying out of
They're gonna pull
nowhere.
up
It's
and be
like
like,
a
where's the
grill.
first car?
Yeah, sure.
I was like, they drove off, I swear.
They made it.
The airbag deployed. I got rear-ended. She was going about 65 miles an hour. She was in a car, and I had a Pathfinder. My car frame bent, and so my car thought I had a side impact as well, and so my airbags deployed, and so now I have tinnitus. Not tendonitis, but tinnitus in this ear, and it'll randomly just like a high-pitched buzzing. It kills me.
Baseball season.
All right.
Pitching Friday.
All right, refresher. Draw back in, take your AirPods out.
Oh.
Sine squared plus cosine squared equals 1 is the one you need to have memorized. It's the easiest one to replace every time. Be familiar with these. You don't have to necessarily memorize them, but be familiar with them that you can recognize, ooh, I think I've seen that somewhere. Can I replace anything? Remember, you're treating the whole thing like a puzzle. And the goal is substitution to make it simpler, right? Your regular algebra rules apply. You can multiply, you can factor. As we got here, you can even rewrite it as a polynomial and then factor it into two binomials. You can do that. This was the one we ended on yesterday, and this was a lot. This is kind of diving right into the harder problems, which is the college level. When we used to have a teacher here, Coach Tyree. Anybody know Tyree? He's already been gone that long.
Yeah.
Hello? Hello?
No phone, no dash.
Hello?
No phone, no dash.
Yes, but this is not Pamela. What are you calling for? Well, if you look at the current record, she sold it a few years ago to a couple out of California, sight unseen. I'm so sorry, but you're late to that. No, I don't right now. But thank you. I hope you have a good day.
You know Pamela?
That's my mom.
Okay, I was like, okay.
Yeah, that's my mom.
Really?
Yeah, Pamela.
Oh, we were all just thinking that you were just.
Yeah, I know you are.
Oh, yeah, if you look, she sold it a
Yeah, I
while
thought you were
ago.
just like bagging it on.
Well, that's why I was like, well, you know Pamela.
No,
You're like, yeah.
No, that's my mom. Okay, so this problem, what I was trying to say was Tyree used to work here, and he was the pre-cal teacher, and he and I used to plan together, and I was like, you know, I'm doing the college pre-cal, he had the high school pre-cal, and I'd be like, what do y'all do in the high school? Like, here's what I have to cover in the college. And I remember him telling me that, like, we just dive right into the deep end with this stuff. So, you know, if you need simpler level 1 challenge problems, you know, let me know and I can find some for you. But college level is, one, it's like we go deeper with the content, but 2, we also go right into the challenging questions. So if you're not getting it, please don't get frustrated. It may just be because it's a level 3 problem. Maybe we need to back up to a level 1. Because I promise, if you can get level 1, you can get level 3. Let's go to this slide right here.
Whoa.
Ignore that.
I was just lying.
It's like looking at the workout beforehand, and you'll never do it if you look at the workout.
Oh, that's your force to.
Well, yeah.
Josh.
Liz on your markers aren't.
That would be Reese yesterday. Bless his heart. He's probably not even strong. And, you know, he's 5, so they're still learning. Their hands are still developing. All right, go to example 4.
Stay around.
So I have a sticky note on mine because I went one way with it and then I went another way with it. I actually have 3 ways here. So let's try this. Take a second, look at it. It does say you're adding. The rules of adding fractions still apply. If I had to say what's the most annoying part of this lesson, it would be if you have to add or subtract fractions, because you have to remember you've got to have a common denominator. So all that stuff applies. Now the good news is the common denominator would just be everything you see, because we're dealing with trig functions, right? You don't have numbers and you got to find the LCD or anything. You don't have to do that. So if you look at this, we've got cosine over 1 plus sine, and then we have a plus tan.
Did you not think?
I saw this a lot of different ways. I'm trying to look at my work here and see which one probably.
Did you not do sine over cosine for tan?
Sine over cosine for tan. Yeah, so that's one of the ways that I have on my sticky note where I replaced tan with the fraction sine over cosine, and then I worked from that. So we can start that route since that's what you see. See, yeah, you can see that. All right, so let's look at this. This fraction here plus tan. So I'm going to, this is a lot of writing, so I'm just going to come over here and say first fraction, copy it down, plus, and then I'm going to replace tan with sine over cosine. So you've got 2 fractions, you've got 2 different denominators. You could go in and get a common denominator. It's like I said though, don't overthink this. Because we're dealing with trig functions, your common denominator is going to be everything you see. So we have a denominator of 1 plus sine, and we have a denominator of cosine. So my common denominator would be 1 plus sine cosine. Does that make sense? So basically each fraction needs the other denominator. So I'm going to change colors so you can see what I'm doing here. This fraction over here needs, and because 1 plus sine is 2 terms, I'm going to put it in parentheses. So I'm going to write 1 plus sine, right? And then technically it's over 1 plus sine. But y'all know that when let me show you a technique. When the goal is to take 2 fractions and add them together to 1 fraction over the common denominator, one of the strategies I use is I go out to the side and I say, what is my common denominator? What did we say it was? Cosine and 1 plus sine. And I go ahead and I write it. So that way I know my goal is 1 fraction. I'm going to have that in the denominator. And then that way when I come over here and I show my work, I don't have to write 1 plus sine and all that here as well, like, because it's already taken care of over here. I'm just focusing on what would be at the top. So that's a technique if you want to use. This one over here needs cosine x, right? Now I'm going to carefully across the top write what I see and clean up anything that will clean up. I see cosine times cosine. Cosine squared. You're good. Then I see a plus sign. Then I see sine multiplying into 1 plus sine. I could go ahead and distribute that. This sign is going to multiply into 1 plus sine and give me sine plus sine squared, right? So I did a lot of work there, and I only showed one line, and I hope you're picking up on the strategies I was telling you to try to minimize like how much you have to write. What do you notice? So don't cancel yet because this cosine on the bottom is attached by multiplication. The cosine in the top is attached by an addition sign. You can't go in there and cancel that. Also remember, you just manipulated it by multiplying cosine in, so don't undo what you just did. Like now what you need to do is look at what you have in front of you. Something should stand out. Remember what I said to memorize.
Oh, the 1 plus sine x is minus cosine.
Do you see sine squared plus cosine squared across the top? Now they're not shoved together, but you can cut gain that. So I'm going to use my highlighter and show you my thought process. I see a positive cosine squared and a positive sine squared. And we said yesterday that anytime you see sine squared plus cosine squared, it's 1, right? So across the top, if you need me to group that, I can, but that I could rewrite this as, oh, that's 1 on top, and then plus sine x. Oh yeah, geometry was used. Yeah. So y'all see where that 1 came from?
No, I want to see this.
And on the bottom, I'm just going to copy it. So I've got cosine. And then now what do you notice? Remember that the only time you can cancel is when, you're right.
Okay.
I'm trying to think, in years past, the most common mistake has been people canceling when you couldn't cancel. So I'm just trying to point out, why are we allowed to cancel here? Well, the top entirely is just 1 plus sine. And on the bottom, an entity, meaning parentheses, is 1 plus sine. So because those match, I can go in and cancel that, which would leave me, now be careful here, don't just write, oh, it's cosine x. It's not cosine x. Where is the cosine? It's at the bottom. There would be nothing left on top, which means a 1. And then on bottom, you would, oops, I undid mine. There we go. And then what is 1 over cosine? Secant. I will reset this slide and see what I did last year, and that would be an alternative one. I personally think the way that we went here is the fastest. Although I'm looking at the other techniques, there's still only 4 lines, but the thought process is totally different. Let me reset the slide. What did I do last year?
I think we should move on.
Oh, I know what it was. Okay, so last year, people wanted me to go ahead and get the common denominator with a 1 plus sign. They left tan as tan. So look at this thought process. So I multiplied by 1 plus sign, which meant my new fraction was 1 plus sign on bottom. Across the top would be cosine plus tan times that. See it? And then so I distributed, and then here I made an aside. I was like, "This, I got to pull this out because there's too much going on here." So I said, "Here's the top. I'd have cosine plus tan. I distributed the tan. Then I went into every single one of them and changed tan to sine over cosine. You see it? And I cleaned it up, and then I ended up with, I would agree. I personally think that's like doing this.
That's like going backwards.
Yeah. That, now someone else, let's see, what is this?
I'm just.
Yeah, we did a key change flip. Where'd this come from? Yeah, I don't know where that came from. I like what we did. I like this.
Yeah, me too.
That's better.
But you see the difference between the thought process and the fact that you still come to the
I
same
didn't pay
answer.
attention.
Let's see this.
Okay, I would have seen it. Ready for that?
Didn't Luke have this?
Yes. Was Trent Baldwin?
I can't
did
see.
he graduate last year?
I really,
Yeah,
Yes.
he was in it.
I just can't see Cooper sitting in here and doing. I just.
Wait, Brandon, so you just.
I can see him sitting in here eating a bag of chips.
Oh
Yeah,
yeah.
because I had to take
Maybe with
economics
beer on the
second
side.
semester.
Look at the next one. All right.
What?
Maybe with a beer on the
Here's
side.
another example of just looking to see, do you remember your basic algebra 2? Like when you can
No.
even have radicals involved. And honestly, y'all, this is on your test. I'm not saying like that exact
Wait a
question.
second.
Listen to me, listen. This is on the test. This should be an easy question. So please make sure you're banking on this as an easy one. I expect you to struggle with the ones where you're changing the identity. I expect you to breeze through the ones where it just says, hey, just multiply or, just factor. Like these should be your level 1 problems. How do you do it? You apply the same rules. So we've got the square root of this mess times the square root of this mess. Because they're both under roots, they're both square roots, we can write it as one giant square root and we can condense it, right? So if we look right here, why does my pen look different?
You made it smaller so we could actually see it. Yeah.
Alright. I don't know. It still looks weird. Anyways, I've got one giant square root, and I've got sine cubed. Don't worry about the x. That just represents the angle. They're all x. Then I've got cosine times cosine. Thank you. So we got sine cubed x, cosine squared x. You'll notice that I tend to put a little space between the trig functions, just so that I remember, like, what I'm working with. All right. Recall. If we had the square root of y cubed x squared, that is the same thing. I just took sine and wrote a y. I took cosine and wrote an x. You got to remember how to take the square root of variables. Okay, well, remember square roots come from multiplying something times itself, right?
Yes.
Do you remember what to do?
Yes.
It
So
will come out as a square root.
There you go. You take the exponent, divide exponent by 2. You don't actually square root. It's kind of weird. Like square root of 9, 3, because I square rooted it. But the square root of x squared. You take the exponent and divide it by 2, because you're basically saying, all right, I need 2 equal groups that got multiplied together to give me x squared. So we're gonna take the exponents and divide by 2. What if it's an odd number? That means, well, let me ask this. An odd number is how far away from being an even number? 1 every time, right? So you're gonna take any odd ones, and you can do this however you want. You could say, okay, this is odd, so I'm going to pull the even out, closest even to it, and then leave the 1 that would be left. And then this is even, so I'm just going to bring it down. And then the odd 1 is always left under the radical, because you can't take the square root to the first power. So, watch how I do this. So if this is helping you understand it, then you can just go straight from that to the answers. If you need to, over here, you could say, this is the square root of sine squared times sine times cosine squared. It's up to you. You see what I did there? That's the same thing. So watch how I get the answer. Y squared, that was sine squared, right? Divide the exponent by 2, what do you get? You get 1, so it's going to come out as sine to the first power. Then go ahead and find the other even one. You got x squared, that was cosine squared. Divide the exponent by 2, what do you get? 1, so that's going to come out as cosine to the first power. What was left under the radical? A y to the first power, so a sine to the first power was left under the radical. And that would be the answer. Now what's annoying about these questions is you look at it and you think to yourself, no, that looks no prettier than what it started as, and they don't. The square root questions don't look any prettier. They're just simplified. Coming over here to this, let me remind you how I got these answers. I said this divided by 2 will work nicely, so that means it comes out. So this is going to come out as y to the first, because 2 divided by 2. This divided by 2 is nice, so this is going to come out as x. And then this one gets left underneath. All right, so what if it was the square root of sine to the 9th power?
Sine 4x square root of sine.
Yep. So that was really fast. So take 9 and you would break it into 8 and 1. And 8 will work nicely. It'll come out. 8 divided by 2 is 4. And that 1 would be left. Anytime there's an odd exponent, there's going to be 1 left in the root. Okay? Because cosine was even, that's why the cosine came out and there's not another cosine. If that had been like a 5, then there would be a cosine squared in the front, right? And then a cosine on the inside. I guess I can leave that. That was a what if. There you go. All right, look at the next one. Rationalize. Okay, so same rules apply here. You're used to maybe square root of 2 over 3. And you would multiply by root 3 over root 3, right? So this ugly nonsense is the same thing as the square root of 2 over the square root of 10.
So
Well, what's the problem?
work it out the same.
Yeah, you do work it out the same. So we're going to multiply by, let me change colors. We're going to multiply by the square root of 10 over the square root of 10. Now don't lose track of what you're doing here. I've seen people do this, and then they come in here and they go, that's 1, and then here's the answer. And it's like, wait a minute, you just went right back to the question. So keep track of what you're actually doing. The goal is to manipulate it. That is a 1. The goal was to multiply by 1 because we're not changing the value of it. Now just multiply straight across. So straight across, these are both under roots, which means you can just shove them together. So that is the square root of 2 tan x. On bottom, you would have tan times tan, which is tan squared. the square root of something squared is nice, so it's just tan. Question, can the tans cancel? No. One's under a radical, one's not, so please don't pop in there and cancel the tans and say root 2 is the answer, because it's not. This is the answer. So I like the radical questions because there's really not much simplifying, like there's no substitution, there's none of that. It's just you know how to do the radical rules with trig functions. All right. We have 3 slides left, and you're gonna want, right?
Sorry.
3? Yeah. You're gonna want your unit circle, that blue unit circle sheet.
Who's on the mom's phone book?
What?
Mom's phone book. Like, she does everything. Did
Let's see.
Miss Holcombe, you know what today is?
No.
Yep.
Oh, it is Thursday.
Yes.
The first spring training baseball.
Oh, is it?
The Dodgers and Padres play tonight, or today. Well, hey, Shohei Ohtani.
My best friend in college,
Oh my
Anna,
god, I forgot he plays for
And
she and I used to go
that new Japanese
to
pitcher.
Disney and go to the spring
Yes.
training
No.
games down there.
I think
The
Yamato.
Braves are always
I
there.
think Yamato will start tonight, and Shohei will be the designated hitter.
If they don't win the World Series, it's the most disappointing super team of all time.
The Dodgers this year. They literally have everybody.
All they need to do is
They don't have a kid yet.
Yeah, they don't have
All right. This sum and difference identities. Let me give you a roadmap.
And Mookie Betts. I don't understand how Mookie Betts is number 2.
Okay. We're going to learn
And Aaron Judge.
3 trig function formulas. These are formulas, okay? Identities.
Do we know
Formulas. Do what?
Do we know her?
Yeah, I'm trying to stall, kind of, but I'm just kind of prepping you. We're learning 3 trig function formulas. They're on your formula sheet, the new one, if you look at it. You're going to want your blue unit circle as well, because these formulas require you to go to the unit circle and to actually pull X and Y coordinates, remember, to answer the question. I personally love these questions because they look so complicated, but it is the same procedure every time. So I'm like, yeah, buddy, I can do this. You know, people think, what are you doing? And it's like, oh, you just have to be in the class to know. It's really, I love these questions. And you can see the textbook thinks you're going to get it and understand it with one example. I'm giving you extras because I'm like, no, we might need to practice some more.
It sounds stupid, but can you just
It's
put those
not.
in the calculator?
Huh?
Can you just put those in the calculator?
No, because the answer is a
Oh, it's in range.
irrational. Yeah, and if you type it in the calculator, now, can you type it in the calculator as a checkpoint? Yes.
Okay.
But your answer has to be in radical form, and these are like square root 2, square root 3, square root 6. So these are ugly decimals that don't go to fractions.
Okay.
All right, I'm going to use my highlighter and highlight the 2 formulas that are right here. Basically, we have 3 slides left. One slide is dedicated to cosine, one's to sine, one's to tangent. So if you want, we can go ahead. We got 1 to sine, and then we've got 1 to tangent. Now the tangent formulas look ugly, and I would agree that they are ugly because they do have fractions, and tan is already a fraction. tan problem takes the longest, which is exactly why there's one example. My paper has 3. What does yours have?
One.
1?
That one.
I think that was because the class was like, I get it, I'm done. I do have 2 more examples we could easily do. We could turn to like a blank spot if there was one. But anyways, tan takes the longest. Sine and cosine don't take long at all. Tan takes forever. Think about it, it takes a long time for some people to tan. There you go. Alright, so let's look at cosine. What exactly is this? This is saying, hey, if you need to find the cosine or sine of an angle measure, go back to, look at your blue formula sheet. Look at your blue unit circle. Let me pull mine up because I'm going to need it. Nope, wait, it was unit 6. Okay, let's do our warm up. Everybody, put your pencil on your blue formula sheet at the sine of 2 pi over 3. Everybody, put your pencil on sine 2 pi over 3. Is everybody's pencil on root 3 over 2? And that would be because you found 2 pi over 3, and I said sine, which means you're looking at the y value.
Oh.
We are doing that again with a twist. The twist is when I say, everybody put your pencil on cosine of 5 pi over 12. You're going to say, wait a minute, 5 pi over 12 is not on the unit circle, right? That's the difference. So we're going to learn how to find sine, cosine, and tan of radian and angle measure, degree measures, that are not on the unit circle by rewriting them as the sum or difference of ones that are on the unit circle, and then we apply the formula. Okay? It's probably easier if we start with degrees. So let's go, we're going to jump around. We're going to come down here to 435. Okay? If I said find cosine of 435, first of all, you should be like 435 is too much, right? So we would calibrate that down. 435 is the same thing as what, y'all?
135.
Careful. How do we calibrate a coterminal angle? You would subtract 360. So 435 minus 360 is what?
75.
Okay. Now, so instead of cosine 435, we're going to actually just find cosine 75, right? Now, go to your unit circle. Is 75 on there? You should already know this.
Oh,
It is not. We only work in 30, 45, 60, 90. Oops, I've already passed it, right? So we're going to take, now here's where we separate. You may go a different route than your neighbor, but your final answer will be the same. You have to rewrite, it's a puzzle, rewrite 75 as either 2 angles adding up to 75 or 2 angles subtracting to 75. You're going to find that I always try to go adding. I don't know why. I just usually just try to think, what can I add to get 75? It doesn't mean it's the right way. You can go subtract. I quickly saw 45 plus 30. Do you see that? Notice I'm picking angles that are on my unit circle. You need to pick angles that are on there. You don't want to pick 60 plus 15. Well, 60's on there, but 15's not, so we're stuck. The goal is you're working with the angles that are on your unit circle. So I'm going to rewrite this. I'm making a note to myself, arrow. My 75 is going to come from 45 plus 30. Here's another aspect where we separate from our neighbor. What if you wrote 30 plus 45? It's still correct. But when you go to apply the formula, your formula is going to look different than your neighbor because you switched the angles. But your final answer is the same, okay? So stay with me. I wrote 45 plus 30. Now I'm going to apply the formula. I'm going to come up here. I know I'm I know I'm working with cosine. I also know I added. So I'm going to come over here to the cosine addition formula. And this is the formula I'm going to use. Be careful. The order that you wrote your angles is what you need to use here. So I'm doing 45 plus 30. So my U is 45, my V is 30. Okay? So I probably need to change the pen so this doesn't get so crowded you can't see. Alright, so here we go. Cosine of 75. I'm applying the formula. I'm going to rewrite this as cosine of 45 plus 30, which is cosine 45. I know I'm right-handed and I'm blocking y'all's view. I'm sorry. Cosine 30 minus sine 45 sine 30. So if you need to, you could come under here and you could say, this is my U, this is my V. And now what you've just done is taken a cosine of a random angle that's not on the unit circle, and you've rewritten it in the formula where now we can answer these questions. Use your unit circle. Remember, cosine means X, sine means Y. Okay? So you are replacing cosine 45 from your unit circle. What's the cosine of 45?
It's root 2 over 2.
It's root 2 over 2. It is literally replacing that. What's the cosine of 30?
Root 3 over 2.
Root 3 over 2. Minus, what's the sine of 45?
Root 2 over 2.
Good. What's the sine of 30?
1 over 2.
1 over 2. Notice I no longer have trig functions in there because now I have the actual coordinate. If you can get here, you get partial credit. Because remember, this is on the test. Remember the test is on paper. So if you can get here, you get partial credit. The most challenging part is cleaning this up so that it's just one fraction with a common denominator. So be careful. Notice that the entire bottom is 2. All the denominators are 2. So this is nice. We don't have to worry about getting the common denominator. Not 2, sorry. They're multiplying straight across. It's going to be what? 2 times 2. I've run out of room. I'll do my best. All right. Maybe I can do this. Look at that. All right. So I'm cleaning this up. All right, right here I have a fraction times a fraction. Goes straight across. Root 2 times root 3 would be root 6. 2 times 2 is 4. Minus, repeat, straight across. Root 2 over 4. Because these are both over the same denominator, I can go ahead and write it as a single fraction. Root 6 minus root 2 all over 4. Now, what if you stopped here with the 2 fractions? That's fine, I give you full credit. But my answer key is going to be, I'm writing it as a single fraction. Now, go to your calculator. Because this is a degree, you need to be in degrees. Go to your calculator. Change to degrees. And I want you to type cosine 435, and I want you to leave it. Leave it. Cosine 435. I'll pull mine up. It's a really ugly decimal, just leave it.
And then do we just put the,
Now I want you to type that fraction in, and I want you to confirm that the decimals match.
Yep.
So that's a safety net for you when you're taking the test.
end it up, and then put them on the other.
Mode.
Oh, in degree mode?
You need to be in degrees, yeah. So cosine 435, leave it, and then now I'm going to type this fraction.
Yeah, that wasn't.
And you get the same decimal. So this answers Brody's question. He said, why can't we just type this in the calculator?
That's stupid.
You can type it in the calculator, but you're going to get a decimal, and the object of the curriculum is, could you do it in your head without a calculator and have it in radical form,
That wasn't
not decimal
radian
form?
mode. This was a degree.
Okay, so that is what we're doing. Now y'all try this. Let's practice this. You try this one here. Let's stick to degrees. Come over here to cosine 165.
Do it again.
Try it on your own. Remember, you're coming, now this one doesn't have to be coterminal. 165 is already within the unit circle. 0 to 360. Think of numbers from the unit circle that could add to give you 165. Or subtract. They can subtract, but y'all know me. I tend to just do addition. Unless I absolutely have to do subtraction. Now, everybody's answers could vary. But basically, you're picking 2 degree measures that either add to 165 or subtract to 165. And those degree measures need to be locatable? No. Findable?
No, but that's definitely not right either. Acquirable.
I have no clue what word would go there. I need ChatGPT.
Huh?
The angles you pick need to be
Findable on the graph.
Locatable.
Locatable does sound right.
Locatable sounds right.
being able to be located. That's
No, they need to be found on the graph.
They need to
I don't know.
come from
I don't know.
the unit circle.
That'll work.
I don't know what y'all, has everyone got a pair of numbers? I just want to kind of
Yeah.
compare. Okay. Did anyone pick 120 and 45? Y'all are my kind of people. That's what I did, 120 plus 45. Doesn't mean you're wrong if you didn't do that.
I want to use
What are the other choices?
135 and 30.
That's what I did.
Okay, perfect. So, as I work mine out,
I'm not
we're gonna have different answers, okay? But our final answer will be the same. Close. Wait, no. But it doesn't have to match, it should match in decimal value.
Oh.
The radical might be different, but the decimal value might be the same, but you did forget to multiply 2 times 2.
Oh. Yeah.
Yell your fraction out loud. So that you know.
Yelled at
Where's,
me.
I need to use cosine 120.
Chloe might freak out. Take that to
I think I did it.
Negative 1/2.
bottom line.
This width is not. What is it? I didn't.
John in the ground.
I didn't ask you to do that.
It's negative
Yeah.
1/2,
Okay.
and the sign must be grouped together.
If I got mine written.
Well, if we get the same answer, make sure you agree.
Oh no, it's wrong.
I got 2 different answers.
Wait. I think that's so. I don't think put square root of 3 over 4. 2.
I have 2 numbers.
Oh my god.
Yeah, that's.
Did you
yeah.
remember to multiply the
Yeah.
denominators?
And get 4. Yeah.
Okay.
4 is my.
I thought I
Did you
looked at it
do,
wrong.
what'd you do?
Okay, I still got it wrong, Kelly.
Did you do 120 and
Hold
45?
on.
Oh wait, I ended with that.
Did you pick these numbers?
No.
Oh.
No, I have that. I just added it to 8.
Oh, no. Remember
I
radicals?
didn't know.
Remember with your radicals, the part under the radical is almost like a variable because it just stays put. It's the numbers in
I'm-
front.
In my mind, they were both under radicals, so they're gonna be fine.
No, that's only, you
But
can
it's
only,
also subtract.
you can only,
The one's negative.
Better.
Negative plus negative equals
she wrote
negative 8.
negative root 8.
Yeah, I had
You only
negative root 8
multiply
over 4.
and divide
That's
numbers under a radical. But if you, whatever you got, type your decimal, like type your fraction in, and then I'll type mine in, and we should get the same thing.
I did it all right. I just can't.
Taylor, I got it right.
Hey, you still worry about partial credit?
I'm mentally
You really want to show your work along the way on this so you can get that partial credit, because if all you give me is this and it's wrong, you get no credit at all.
It'd be fine if it was negative.
Yes, yeah. Okay. You saw how easy, is it okay to say easy?
That one was.
You saw how
Easy.
just, like, there's no real challenge, just having to come up with it, right? Okay, we're gonna go to when it's in radian measure.
So we need to go back
It's
to
the same thing, y'all, it's the same thing. The problem is people hate fractions. So first of all, I'm gonna show you a trick to work with the fractions, or second of all, and you will not see me do this because I don't like the idea of not trying to push myself to work with fractions. You could always change the radian to degrees and then finish the problem with degrees. You do know how to convert from radian to degree. So you could change that to degrees and then work from there. I will not do that because I just want to stick with the fractions and push myself. But you could say, what is 5 pi over 12 in degree? You'd multiply by 180 over pi. Pi's would cancel, and you would have your degrees, and you could go from there.
I like that.
You can do that, okay? So keep that in the back of your mind. No, because what would happen is your final answer is going to be this, regardless of what mode it started out in. Yeah. But I want to push you and encourage you to work with fractions. All right, so we've got 5 pi over 12. Here's my trick for you. I'm going to come over here. This is my little side note. I got 5 pi over 12. The goal is two fractions that either add or subtract to give me 5 pi over 12. We want to work with numbers that will reduce with your denominator that's already in the problem, okay? So the denominator that's there, think of numbers that reduce with 12. So my mind's thinking 2, 3, 4, 6. Those are the numbers you want to work with because the goal is to have pi over 3, pi over 4, pi over 6, pi over 2, 3 pi over 2. All those radian measures, you know what I mean? So I've got 5 pi over 12. You might think, oh, add 1 plus 4. The goal, you focus on the numerator. The denominator has to stay put. So this is going to be something pi over 12, plus or minus, depends on which way you go, something pi over 12. You're manipulating the 5. Break it apart. Well, if I do 1 plus 4, 4 over 12 is nice, that reduces, but 1 over 12 doesn't reduce. And there's no 1 over 12 on your unit circle, so that won't work.
3 and 2.
Then you might think 3 and 2. 3 pi over 12, 2 pi over 12. So let's try it. 3 plus 2. Check your reduced fraction and make sure it's on the unit circle. So 3 pi over 12, I'm going to draw an equal sign and carry this over here. 3 pi over 12 would be pi over 4, right? And then copy the plus sign. 2 pi over 12 would be pi over 6. Winner, winner, chicken dinner. Both of those are on the unit circle. Now you finish the problem like this. Why did I did 9 minus 4. I did a minus this time.
What?
I don't know
Where?
why.
Where?
I saw 5 and I thought, oh, 9 minus 4. 9 over 12 reduces, 4 over 12 reduces. But anyways, you could have done that. It would change what formula you use. We'll run with this. So this is what we're running with. I'm going to put a check mark because both of those are on the unit circle. Oh, you're going to go back? So here we go. Our cosine of 5 pi over 12 is going to be rewritten as cosine of pi over 4 plus pi over 6. And now we're going to, that's our u, that's our v. So we plug it into our formula. This is our u, this is our v. So we got cosine u, cosine v, minus sine u, sine v. Now you get your x and your y's from the unit circle. I can't look at mine because mine, I did subtraction. All right, let's see. Pi over 4 is always root 2 over 2. Pi over 6. What's the x coordinate? Root 3 over 2? So the y coordinate must be 1/2. And I've run out of room there, so I'm going to bring this over here. It is, yeah, because if you think about it, you're calibrating to things from the unit circle. So yeah. Now the only time you might have some nicer stuff happen is when you've got those quadrantal angles, which means the sine or the cosine may be the number 0 or 1 or -1, and so nicer stuff happens there. So this is the answer, or as a single fraction. Did I mess up? Good news is, this is the same thing with sine. It's just the formula is different. But it's the same concept. You're finding the sine of an angle that's not on the formula sheet or unit circle. So you've got to break it apart into something you can either add or subtract. I guess it might be fair to say you don't need 3 practice problems of sine. So let's do the one with the radian, because that's the most uncomfortable one. Let's all turn and practice this one right here. So remember, the denominator stays the same. You're working with numbers that would add or subtract to 23 and reduce with 12. So stick with 2, 3, 4, 6, 9, numbers like that. Let's see what everybody's numbers are. I will tell you, I came up with an addition.
Oh,
Imagine that.
I wasn't paying attention.
Oh, but you could do a. No, you
No, do not.
I'm not. Why did I go with that? Why did I not do?
23 or 12. We do
If I had picked that number, that would be. I don't like the fraction. I don't know why I've done. All right. We're gonna look to see what everyone's numbers are.
24 minus 1.
No, you can't do -1 because 1/12 is not on your unit circle. I'm glad you asked. 24 minus 1 won't work because 1/12 is not on the unit circle. What if you did 25? No, if you did 25 minus 2, 25/12 won't reduce. So that doesn't help. I went with an addition.
You do 36 minus
Good Lord. Oh my gosh. I went with an addition. I don't know why I did this.
What numbers did you use?
I picked 15 and 8. And I'm standing here and I'm thinking I should have just picked 20 and 3. Did anybody pick 20 plus 3? 13/12 won't work.
I like whatever you said.
20
I
and
did 9. How would 13?
20. So let's
14.
walk through, like, if you picked a number, how would you know if it doesn't work? I'm going to go back to what he said. He picked 24 minus 1. And the problem is, yes, 24/12 reduces, let's see, by 6, that would be 4 pi over, 12. It reduces by 12. So that would be pi over 2. That's great. That's on the unit circle. But the problem is that one's not. So that's how you know, okay, back to the drawing board. I picked, on my paper, don't know why, but I picked sine of 23 pi over 12. I rewrote it as 15 pi over 12 plus 8 pi over 12. Because 15/12 reduces to 3 pi not 3 pi,
See,
5 pi over 4,
power.
which is on the unit circle. And then 8/12 divided 4 out reduces to 2 pi over 3, and that's on the unit circle. So those are the ones I picked. As I was standing here, did I mess up?
Yeah, your first one, it's 4 pi over 3, right? Am I crazy? Or 5 pi over 3?
This one?
It's 5 pi over 4. She's probably wrong. Because if you divide them both by 3, if you simplify them both
If
by
I
3,
divide this
yeah,
by 3, I get 5. If I divide this by 3, I get 4.
Okay.
Right? Okay, not a problem. I'm glad you asked me. So that's what I picked. Does my paper even say that? Yes, it does. But then as I was standing here waiting for y'all to tell me, what y'all pick? My mind saw 20 plus 3. I don't even know if that works. I'm going to check it right now. So 20 and 12 reduces by a factor of 4, right? So you get 5 pi over 3. And this reduces by 3, so you get pi over 4. Definitely works.
oh well, I'll already do it that way.
Either, it doesn't matter. But you see, that's probably the hardest part, is just coming up with what numbers am I going to use. Because then from there on out, you're using the formula. Be careful with the formula. Sine is a little different. you're gonna notice that the formula is, did you apply the formula wrong?
Yeah.
You gotta be careful. The formula is definitely different than what we were doing with cosine. Let's see, so this would be, this whole thing I do up. Alright. So I got addition, and this is, I got my U and my V, so. Watch your signs. If they're negative, write negative. When they go to multiply, negative times negative makes a positive. The formula is different. Look at, you see right here? It's totally different formula. And you're going to have those formulas. I'm not asking you to. Yeah, I'm not asking you to memorize. So this would be positive root 2 over 4. And then, see here I have a plus, but then I'm going to multiply these and get a negative. So I'm going to go ahead and write minus to account for that negative. But if you don't want to, it would look like this. Plus negative root 6 over 4. When you put it together, you would write root 2 minus root 6 all over 4. Okay, I would accept either one. I'd love for you to get here though. Now, I know we get out in what, is it 5 minutes?
Yeah.
I would like to show you tangent, but Monday what we will do is we will spend the first 20, 30 minutes homework questions, questions on tangent, anything like that. And
So could you like rework another one Monday morning?
Yeah.
Just to show us again?
I need to show you tangent because I want you over the weekend to be working on your 7-1 homework. Remember, our goal is that exam to be that week before another long weekend.
Before spring break?
And the final exam before spring break. That's the goal. That is chapter 7 exams before spring break. Go to TAN. We'll work with degrees. It's the same thing if it were radians, but we'll work with degrees.
What is that formula?
The formula is insane. Don't worry about the formula yet. Everybody take a second and think of how could you get 15. Now this particular one I went with a subtraction. 15 is so small I couldn't think of two numbers that nicely add to 15. So I went with 45 minus 30.
Please excuse the interruption. The following student needs to report to Mrs. Lane's room, which is room 213. Today, during first flex. Please report to Mrs. Lane's room, room 213. Today, during first flex. Gabriel Dobbins, Sarah Hobbs, Elena Godfrey, Simone Horngate, Hannah Crow, Cassidy Clemente, Haley Hampton,
Can you all
Noah
follow
Birchfield,
as she's doing
Robbie
that?
Burdett,
Okay,
Lexi Hobbs,
so
Emma
subtraction.
Sturdivant, Chloe
Go to
Wilman,
subtraction for me.
Tabitha Brown, and Madeline Barker. Thank you.
Watch your U, watch your V. Be careful. Okay? U, V.
I agree with that.
Now, the problem with the tangent, it's the same stuff we've been doing. The problem is, not only is the formula ugly because it's a fraction, it's a giant fraction. What is tan?
Side of it.
Tan is a fraction as well. So we've got a fraction within a fraction multiple times. So here's something I taught the kids last year and it really helped. There's only 2 scenarios of ugly tan numbers. And that's if it's on the 30 or the 60. Everybody look at 30 and 60 on your unit circle. That's when those numbers are 1/2 or √3/2. Tan of 45 is 1 because if you look at the unit circle, X and Y match. Tan of a quadrantal angle is either 1, 0,
Or negative 1.
oh no, wait, 0 or undefined, because 0's in there. So it's always 0 or undefined. And by the way, it'll never be undefined because then the problem would be a waste of time. So the only issues are if you have tan 30, tan 60. So what I told kids last year was when you start this test, go find tan 30, tan 60 very quickly or have it memorized. And then you don't have to worry about when you get to this part. You can just plug it in, okay? So this is going to be the first time we have to actually find it, which is why it's going to be like, Miss Holcombe, this problem's stupid. You wouldn't find it every time. We're going to need tan 30. So we're going to come over here and do an aside. We're going to find the tan of 30 over here. So we're not finding it in that mess. Real quick before you leave, tell me what the coordinate point for 30 is. What's the point?
3 over 2.
And
1/2.
1/2. Okay. Remember that tan means y over x. So y is 1/2. X is √3/2. Keep, change, flip. I gotta erase that before my sophomores come in. They're gonna be like, Miss Holcombe, what did you write? Keep, change, flip. Clean it up. It should look familiar, right? And then
It's gonna be √3/3.
rationalize.
Okay.
So now when I go to 3.
Can we finish this Monday?
Yeah, but I just wanted to show you. So now when I would go to my formula, I plug in √3/3 for tan 30. Tan 45 is just 1, right? So the only problem here is this would end up being a fraction within a fraction. You can come on in. And I will actually just go ahead and finish it on here. Save it in the video if you just want to scroll the video and have it in your notes.
See, that class was so educational until you got there. Now I want to eat a brick.
Thank you.
Now I'm like, I'm talking. Oh, progress report.
So the coordinate point for 45 is going to be √2/2 divided by √2/2,
I hate my
which is 1. Oh, it looks good.
Nuh-uh.
Feels
I
very
hate
good.
my braces.
Have you got trouble yet?
So this is what I would get. I'm running out of room, so I'm gonna write the top would be the same.
Everybody?
This would multiply. So I've got that.
Colby, I thought you sold. Nope.
Here's where it gets ugly.
Definitely sold.
You gotta have a common. I know. You gotta have a common denominator. Fine. You gotta have a common denominator. What I like to do is I write the 1. I would take my pencil. I would erase the 1, and I would rewrite it as 3/3. Because the denominator of that fraction that it needs to combine with is a 3. Yeah. So now I can see, now reading straight across, be careful. So across the top here, I have 3 minus √3 all over 3 across the top. Then I got a big fraction bar. Across the bottom, I'm almost done. 3 plus root 3 over 3. And then you have to keep, change, flip. This is why, remember me saying it takes a long, I know. Tan is a pain in the butt because it takes forever to get to the final answer. I would keep, change, flip. So keep it, change it, flip it, and then the single 3s cancel, and this is where I'm okay with you stopping right here. Now, honestly,
That looks like what we just had.
I know it does. Honestly, the textbook wants you to keep going by rationalizing the bottom, and it's a hot mess. So I'm okay with you getting here. Now this is full credit.
I do know how to rep questions.
Yeah, you would multiply by, because it's 2 terms, you would multiply by 3 minus root 3. But this would be full credit right here. This would be half credit. Right there. No, if we started with tan, everyone would have shut down a long time ago. Sine and cosine are easy breezy. Tangent is annoying.
That's why you only have